Now I will show you how to build a recognition system for human speech. Uh, Speech signal is an analog signal. It's an air pressure. It can be converted to digital using the same methodology used to convert analog image to digital image. The analog signal will be passed to analog to digital converter. Applying the analog to digital converter functions, sampling, quantization, and encoding, we can get the digital voice or digital speech signal. Here the speech signal speech file size will depend on the recording time and the sampling frequency. Sampling frequency mean how many samples will be generated in a second. The output signal or the digital signal will be a set of samples. These samples represent the voice amplitude, and they are organized into two columns. If the voice signal is stereo, or one column if the signal is mono. So here we can see that it is easier to deal with the voice because the voice is a uh, two-column matrix, and it's easier to implement them. If we look for the color image is a 3D matrix, and the number of rows and number of columns are very huge. This the material will be uploaded into ResearchGate. The link I will give you the link to the material. There is a special function included in the materials which convert any spoken phrase to voice. Here are some sentences that were treated by the function and converted to voice. Sampling frequency, recording time, size in samples, and size in bytes. Here the voice sample will need a double type value. It's 8 bytes, and the values of the sample will range from -1 to +1. Here a plot of wave example. To build the recognition system for the speech, we can use the same methodology used to build the recognition system for images. Here we can follow the the required steps needed to create or to build a special system which can recognize the voice. Here we have to notice that the recognition system can recognize the human and also can recognize the spoken word or words. These words can be used as a voice signature to identify the human or the person. First of all, we have to select the speech signals. These speech signals must be stored in a special folder, which will be called, which we will call the speech files database. The first step in building the recognition system, we have to select a method to create features for each speech. This method, we can use modified local binary pattern method, can use clustering method, packet wavelet tree decomposition, statistical methods we can use. Here we, in this example, we will use modified local binary pattern method. This method will be programmed using programming language such as MATLAB. We have to run this program for each speech to create the features database. After creating the speech signal features, these features must be added to the features database. The feature database here will be the same as in image recognition system. It will be a two-dimensional matrix. Number of rows equal the number of features in the feature vector, and the number of columns will be equal the number of speeches in the speech folder or in the speech database. Here we use the modified local binary pattern method. The speech signal must be reshaped into one row if it is mono, or if it is stereo. We get a one row representation of the speech file. Then for each pixel, we apply the methodology of modified local binary pattern to get a feature within the range 0 and 3. At the end, we will get the repetition of these values in the speech file. These repetition will form the features of the speech signal. After that, we have to add the extracted features to the features database. Then after manipulating the last speech, we have to save the features database to be used later in the steps of building the recognition system for the speech. Here I use 5 wave files. I think cat, dog, and some other animals. Here are the features, 4 features, and 5 speeches. The features are unique for each speech signal, so we can use this feature as a signature or a primary key to identify the voice signal. The second step is creating artificial neural network. This process is the same as in color image recognition system. We have to select the input dataset, which is the features database. If needed, we have to normalize. I think we need normalization because the values are too too high, so we can divide the features by a big number to get a suitable for calculations input data set. After that, we have to define the targets. The targets here is a classifier from 1 to n. Each number will be used as an index or will point to an index of the speech from the speeches stored in the speech database. The same artificial neural network architecture here can be used with two layers. Feed forward artificial neural network we can use, or cascade feed forward artificial neural network. The minimum architecture is two layer, input layer with 4 neurons and output layer of 1 neuron. Here, if we want to recognize or to classify the persons and the spoken word, we can use 2 neurons in the output layer. The first will classify the person, the second will classify the spoken word or spoken sentence. The activation function for the input layer will be log sig or tan sig. The activation function for the output layer will be linear. We have to initialize also the weights to 0 by initializing the artificial neural network. Some parameters will be selected, such as error. Error must be equal 0, and the training cycles we have to select a number just sufficient to move the error to 0. Then we have to train the artificial neural network. After that, we have to test it. If the outputs are acceptable, we have to save artificial neural network to be used later as a speech classifier. Here are some outputs of the trained artificial neural network. The outputs are correct and the error was equal 0. So we can save the SpeechNet to be used later in the following step as a speech classifier. The last step here is using artificial neural network. Here we have to load the neural network. We have to get the speech features. Here we can use a speech, then applying the feature extraction method, we can extract the features. Then the features will be normalized and passed to artificial neural network. The artificial neural network will correctly compute the speech signal classifier. The second way, we can directly input the features. If we know the features, then these features must be normalized and passed to the artificial neural network in order to get the classifier. Here, according to the computed classifier, we can manipulate or we can process any reaction or any action, any process which is related to the recognized voice. Some examples of running the classifier. Here we directly input the features and we get the classifier for which points to the horse. The programs are listed here in this material. Here, the feature extraction program, then artificial neural network creation and training program, then using artificial neural network as classifier. First method by extracting the features. Second method by directly inputting the speech features. And at the end, there is a speech recording function which can be used to record any written sentence. You can use this function to create speech files with various sampling frequency and with various sizes. I think you can enjoy the process of building speech recognition system for your using your own speeches and using your own actions which are depend on the computed classifier. Thank you and goodbye.